a paleontologist studying fossilized teeth from the Riversleigh World Heritage Area in northwestern Queensland, Australia, has proposed an entirely new taxonomic order of marsupials. Published in June this year in the Journal of Paleontology. The proposed name is Keeunamorphia. If the classification holds up, it becomes the sixth recognized order in the marsupial family tree, standing alongside the ones that gave the world kangaroos, koalas, and Tasmanian devils. The animals themselves were small, probably weighing somewhere between 25 and 200 grams, roughly mouse to rat sized. Insect-eating creatures that lived in the lush rainforests that once covered northern Australia. Based on the fossil evidence, the lineage may have persisted for around 35 million years before disappearing entirely. About 15 million years ago. Let us sort the signal from the noise. Understand how big a claim this actually is. Order sits high up the biological classification ladder, well above genus and species. A rank reserved for genuinely distinct branches of the family tree. Australia's marsupials are currently organized into 5 recognized orders, including Diprotodontia, which covers kangaroos, koalas, and wombats, Keeunamorphia, which covers Tasmanian devils and quolls, and Keeunamorphia, which covers bandicoots. Researcher Matthew Churchill's proposal is that these particular teeth do not fit cleanly into any of those 5 existing groups. They show a distinct cusp pattern, the arrangement of bumps and ridges used for chewing, that sets the animal apart from every known relative. Under the standard rules of taxonomy, a distinct enough anatomical pattern justifies proposing a new order rather than awkwardly forcing the fossil into a category it does not actually belong in. It is worth explaining how paleontologists get so much information from something as small as a tooth. Teeth are the hardest, most fossil-resistant part of a mammal's skeleton, and their cusp patterns are remarkably conserved across evolutionary lineages, making them unusually diagnostic, often more informative than almost any other single bone. From cusp shape, size, and wear patterns alone, researchers can estimate body size, infer likely diet, in this case insect eating, and compare subtle structural differences against known lineages to work out where an animal sits on the family tree. Riversleigh itself, where these fossils were recovered, is one of the richest fossil deposits on the planet, so densely packed with ancient bone that some individual limestone blocks contain hundreds of fossils. It has been a UNESCO World Heritage Site since 1994. And it is still producing major discoveries like this one, decades after excavation first began there. Consider why this actually matters beyond one new name. The standard picture of Australia's marsupials has generally assumed a relatively straightforward story. One ancestral lineage arriving and gradually diversifying into the kangaroos, koalas, and other groups alive today. A genuinely new order surviving 35 million years and then vanishing completely, leaving no living descendants, suggests something messier. That early Australian marsupial evolution involved more independent branches experimenting in parallel than the fossil record had previously shown. Some of those branches, this one included, appear to have simply run their course and gone extinct rather than evolving into anything that survived to the present. That reshapes the picture from a tidy single trunk with branches peeling off toward something closer to a genuinely bushy family tree, full of dead ends that researchers are only now starting to uncover. One fossil deposit at a time. A real caveat belongs here. This entire classification rests on isolated fossil teeth, not a complete skeleton, and mammal taxonomy built on dental evidence alone has a genuine history of getting revised, sometimes substantially. Once more complete material, a jaw, a skull, limb bones, eventually turns up and either confirms or overturns a proposed new group. This is one researcher's proposed reclassification, published in a respected, peer-reviewed journal, which counts for real scientific weight. But a taxonomic rank as significant as an entire new order is exactly the kind of claim the wider paleontology community actively debates, tests, and sometimes redraws over the following years. Not something settled the moment a single paper appears. Because the physical evidence is limited to teeth. Plenty about this animal's actual appearance, behavior, and full anatomy remains inferred from comparison to relatives, rather than directly observed. Quick recap. Fossilized teeth recovered from the Riversleigh World Heritage Area in Queensland led paleontologist Matthew Churchill to propose Keeunamorphia, a potential sixth order of Australian marsupials that may have persisted for 35 million years before going extinct around 15 million years ago. Published in June in the Journal of Paleontology. So, signal or noise? Signal. This is real, peer-reviewed fossil evidence, and if the classification holds up under further scrutiny, it genuinely adds a previously unknown branch to how Australia's marsupials evolved. Noise risk shows up only if you treat one paper's proposed new order as instantly settled fact. Classifications built on teeth alone get revised often, and paleontology consensus typically takes years, not weeks, to form. The honest takeaway: a genuinely exciting hypothesis worth watching closely. Not yet a rewritten textbook. Subscribe for the discoveries explained with the uncertainty left in, not smoothed over. Signal from the noise. Every week.